Thanks for coming, everybody. I just want to say good afternoon, and thank you for coming to my talk about revolutionizing video processing with AI. So, in this talk, we're going to go over how to create a enhanced video processing pipeline. Um, these are some groundbreaking developments that we've seen where we're integrating AI inferences into Babit Multimedia Framework, or BMF. This is a synergy that's just not just enhancing the current capabilities, but paving the way for a new innovation in applications in multimedia. So I'm Joshua Alphonse. I was actually previously at ByteDance prior to this conference. I was a staff developer advocate for our open source program office, where we oversaw over 50 different open source projects from the ByteDance team. That goes from JavaScript runtimes to video processing pipelines, you name it. Now, I'm actually leading product and DevRel at PremAI, which is a smaller startup or early stage, and we focus on creating performant small language models. So we're doing some cool work with Marvel and some other IPs that they have coming out as well, where we're creating custom models for them. And we have work alongside with a lot of other startups and some other up-and-coming companies like Grok, Anyscale, so forth. So we're an entire developer platform that helps you integrate small language models and large language models, along with a fine-tuning agent, in order for you to alleviate the machine learning process. Now, even though I don't work at ByteDance anymore, it's still completely relevant to this video processing pipeline that we have here. Because of function calling agentic AI, this is another piece that we can add into it. But in this talk, I'll go over some of the basics behind Babit Multimedia Framework, the reason behind it, and what we're doing with it. So again, let's begin with an overview of BMF, or Babit Multimedia Framework. This was developed by the team in China in ByteDance. And it stands as a versatile and powerful multimedia processing pipeline, or framework. And it's designed to handle a multitude of tasks, from video transcoding to virtual reality applications, you name it. In this era, video is not just content. It's a language, and it's a means of expression to everybody, you know? So you, me, and anyone can capture any moment in time and share a story online. So similar to how people are using TikTok, CapCut, Instagram, you name it. It's remarkably simple to create and immerse in these digital narratives right now. But if you pause for a moment, you think, what really happens in this magical space between when a video is uploaded and when it lights up on your screen, and you could be anywhere in the world? So that's a story that is often seldom told, and a journey that's unseen. So yet, this is where the true magic unfolds with Babit Multimedia Framework. Babit Multimedia Framework is processing over 2 billion videos a day on TikTok and CapCut, and it's completely GPU enhanced. We've actually worked alongside with NVIDIA, which I'll go into a little bit later. But it's great for AI machine learning engineers, especially those that are coding in Python, of course. Multimedia developers, and it's completely cross-platform, and it's supported by a ton of different languages. It's not entirely agnostic to all languages, but some of the main ones. So behind the scenes, there's a key player with Babit Multimedia Framework. It's FFmpeg, and this is an open source, household name for video processing in the industry. Babit Multimedia Framework is also open source, of course, but it's a fork of FFmpeg, offering comprehensive cross-platform solutions for audio and video. FFmpeg handles almost any task related to multimedia processing now. And more importantly, FFmpeg is also open source, right? So computer processing of videos fundamentally involves code executions using filters, and FFmpeg stands by offering a wide range of these filters, meaning diverse video editing requirements. And also, uploading a video to a platform typically involves basic steps like transcoding, watermarking, easily handled by FFmpeg. However, contemporary demands for higher video quality means platforms also enhance videos, such as using super resolution, which is actually produced from AI models with BMF, or for lower resolution videos, extending far beyond FFmpeg's capabilities. FFmpeg is based on low language or D+ development. Integrating code from different languages is very troublesome sometimes, so let's dive into some of the fundamentals. A major feature of BMF is that it supports multiple languages, like Python, Go, C++, and Python is widely utilized in the AI and server development for BMF, leveraging frameworks to significantly expedite the creation of modules like super resolution and frame interpolation, all done from machine learning and AI models. This efficiency can have the development time from 2 weeks to just 1 when we're working with video pipelines. This impact of these modules is clear, giving developers the chance to help creators enhance their content. And ByteDance is a social media company, so this is where we dive into. So for example, you can greatly enhance an image quality of older movies, showcasing power of super resolution and revitalizing the classic content, which I'll show you next. But before that, let's go over some of the architectures behind BMF. We have our application layer, our multi-language layer, and then also the module layer where all the AI stuff happens. So what sets BMF apart is that its modular architecture allows for flexible and scalable video processing, and this framework processes hundreds of millions, and nowadays over 2 billion videos a day, proving its efficiency in terms of functionality and capability. The performance is honestly amazing, and we have a lot of great contributors. In the application layer at the top, there's support for a diverse range of requirements, including video editing, analysis, live streaming, and video conferencing to fulfill these needs. The underlying module layer on the bottom here, the second layer there, houses separate functions like encoding, decoding, efficient staff segmentation, video rendering, and also 3D reconstruction, all organized into these distinct modules that you can create and basically plug into BMF whenever you want on the fly. So video encoding presents a complex challenge with the need for compatibility across formats being crucial for video software. So this is basically what we would build with BMF, right? This is just a very simple example. And this is where we're using different AI models on top of unprocessed video and processing it, and using a text-to-image model to layer right on top of an unprocessed video, thus processing it. Now, we can also change this with other models to de-oldify this video and bring color to a black and white video. But the power behind this very simple example is the fact that I can layer language models right on top of videos that I'm processing at speed and scalability. Now, I can then use this for watermarking on the fly or adding different elements to a video wherever I like. So when you're looking at TikTok or CapCut and you see a bunch of those funny filters that people are wearing on their heads, just remind yourselves of what BMF is capable of doing with different AI models. And this is also super powerful for the multi-language support, and Python capabilities are pretty much endless when you're integrating it with BMF. The applications of BMF are enhanced with AI are diverse. In media production, it enables sophisticated editing and post-production processes as well. It's not just for live streaming. In surveillance, it aids in real-time threat detection with, again, another AI model on top. For sports, it offers advanced analytics for performance assessments, and in entertainment, it paves the way for interactive and immersive experiences. There's just a few examples here that I've shared, but this can be applied across various different industries. One of the most significant advantages of combining BMF with AI models in real-time processing is that the framework has asynchronous scheduling for cross-device data transmissions capabilities, and means that we can process videos faster and more efficiently than ever before. This is critical for applications like live streaming and video conferencing, where latency is the utmost key concern. The optimization provided by AI ensures that high performance and quality, and even demanding in some of these high demanding scenarios. And again, when you're working on Instagram Live or TikTok Live, you don't want to have any type of latency happen within a live stream. So again, this is another piece of an AI model right on top of BMF, where we can de-oldify an old video that's black and white and use an AI model to enhance it and give it some color. It's pretty amazing what you can do. We have facial recognition and classification that works right on top. And integrating AI inferences into BMF opens up a new realm of possibilities. BMF's capabilities with various data, formats, languages like Python and Go, or C++ allows for these seamless incorporation of AI tools. So this means you can leverage the power of AI for a more accurate, for advanced encoding, OpenCV, for image transformations, or PyTorch for deep learning. So this entire framework is open source and it's flexible for integration. So video encoding itself, to elaborate on this point, this is the term that describes the process of converting raw video, which is like too large of a task for broadcast or streaming to take up. Originally states when camera captures it into a compressed format that makes it possible to transmit across the internet. So without encoding, there would be no streaming. So remember that scene from Willy Wonka and the Chocolate Factory, and when Mike TV jumps in front of the Wonka vision, and the machine appears on the TV across the room, and now he's 2 inches tall. The machine took his larger self and broke it down into countless tiny pieces and transmitted it through the air. And this resembles, how poor Mike was encoded and turned into something else. So this is simple, a simple way to encode a video with BMF. Just compared to the other solutions, this code is really easy and readable. If you had to compare this to something like FFmpeg, completely. We simply use an encoding function, and we list out our streams, and we process the changes and the resolution of the video from this example. And then next, with the encoding again, we just take the output patch, and we also can change the width, the height, and how the video is being presented, and add more audio params as well to add audio effects. So if you wanted to add any type of AI models to enhance the audio or change something, you can. So then we have transcoding. If we go back, transcoding is an umbrella term that refers to taking already encoded content, decoding it, and compressing it, and implementing alterations, and recompresses it before the last mile delivery. So transcoding might involve making smaller changes, such as adding watermarks or graphics, kind of similar to what I showed you with the panda. So again, super easy to implement into your workflow with BMF. And you can chain together several operations on top of one another. You can trim the stream and start at specific times and different durations if you like. So you can just loop over the overlay stream and list and create from the list that we created earlier, and each overlay streams and indexes over. So, and yeah, pretty much it's the same chain again. And then we have decoding, right, which is just the process of the act of decompression and encoding the video data to display it and alter it in any type of way. So when you want to fit it on your phone or have it on the browser, this is the way that we can resemble the packets in the right order to display it on a certain screen. So we're at the brink of a new era of multimedia here with BMF and some of the other contributions that are coming forward from all of our open source contributors and maintainers as well. So this fusion of AI and BMF together for video processing is just a step forward, but it's also a giant leap compared to where we were before. So looking to the future, integrating AI with BMF holds immense potential. So NVIDIA GPUs have one or more hardware-based decoder or encoders which provide a fully accelerated hardware-based video decoding and encoding for several popular codecs. Pretty amazing. So nowadays, many video processing rely on deep learning methods, or with deep learning modules usually run on NVIDIA GPUs, and the library is developed by NVIDIA. So we actually worked in collaboration with them while I was at ByteDance with NVIDIA. So transferring the decoding and encoding from CPU to GPU has a ton of benefits. So for video processing that uses deep learning models, they can use NVIDIA TensorRT to accelerate the inference. So TensorRT is just an SDK for high performance deep learning inferences, and that's pretty much what you need to know on a high level about it. So with AI, video analysis and enhancement reaches new heights. Imagine being able to detect objects or analyze facial expressions with all these different AI inferences on top. this makes it all possible. And the integration not only proves the accuracy of the video, but also proves the quality of such. So it's essential for modern content building and creation for multimedia applications. So we have some other GPU hardware accelerations. We could talk about hardware transcoding, hardware filtering, and inference module, but I don't have much time left because this is a lightning talk. But in the GPU transcode code folder that you'll get from BMF, we provide various examples to show how to use GPU decoding and encoding as well as how you can combine FFmpeg with CUDA and filters within BMF. So for GPU transcoding, you should combine the GPU encoding and the other methods that I mentioned before. Since all this intermediate data are in the GPU memory, we don't need to consider any extra copying anymore at all. And you'll see some more information once you download BMF. Hardware filtering sings, these filters are pretty simple, honestly. Just pass the filter's name and the parameters through the FF filter, but you should be careful about where this data is reserved. And also GPU inference module, again, is just like for video processing that uses deep learning modules on top of BMF using NVIDIA TensorRT to accelerate the inference. So again, we're on this brink of the new era of multimedia. And if you have any questions, and if you want to learn about some of the work that we're doing with Prime AI and some of the work that I did previously while I was working at ByteDance, feel free to reach out to me. I'm actually in the middle of making a new open source project between BMF and Prime AI as well to do some agentic AI work to actually edit videos from a language model. So if you want to learn anything about that and our agentic fine-tuning process that we offer on the platform, feel free to find me and contact me. Thank you all.